Have you ever been stuck in traffic, just staring at the bumper in front of you and thought, man, I wish this car could just drive itself? Well, that sci-fi dream is becoming a reality, fast. So how in the world do these cars actually do it? Let's get into it and break down exactly how these amazing machines see, think, and act. I mean, this really says it all, right? This is the promise. It's not just about convenience, it's about completely changing how we travel. It's about freeing up our time and, hopefully, making our roads a whole lot safer. But how does a machine even begin to handle something as complex as driving? You know, the easiest way to wrap your head around this whole thing is to stop thinking of it as a magic car and start thinking of it as a very, very smart robot. It's got sensors for its eyes and ears, a powerful computer for its brain, and the steering and brakes are basically its muscles. And like any robot, it follows a super clear, logical process. And that process boils down to these three simple steps: sense, think, and act. That's it. First, the car has to figure out what's going on around it. Then, based on that information, it has to decide what to do. And finally, it has to actually do it. This simple little loop is the foundation for everything a self-driving car does. So let's dive into that first step, sense. For a car to drive itself, it needs to see the world better than we can. It needs superhuman senses. And it can't just rely on one thing. It needs a whole team of advanced sensors working together to paint a full 360-degree picture. And here's the team lineup. You've got cameras, which are basically the car's eyes. Then there's LiDAR, which uses lasers to build this incredibly precise 3D map. Radar is great because it can see through rain and fog to track how fast things are moving. Ultrasonic sensors are for up-close stuff, like when it's parking. And finally, GPS and super detailed HD maps tell the car exactly where it is in the world. Okay, so this brings up a really interesting point when we compare the two main vision sensors. Cameras are awesome for recognition. They can read a stop sign just like you can, but if it's super foggy, they're basically useless. LiDAR, on the other hand, creates a perfect 3D picture no matter if it's day or night, but it can't read text or see color. So, since neither one is perfect on its own, the car needs to get them to work together. And this is where the real magic happens. It's a concept called sensor fusion. The car's brain knows better than to trust just one source of information. It takes the color and the context from the cameras, that super precise 3D map from LiDAR, and the speed data from radar, and it merges them all into one single trustworthy view of reality. It's the only way to cover for the weaknesses of any one sensor. But the car has another secret weapon: HD maps. Now, we're not talking about the GPS on your phone. These things are on another level. They are preloaded, unbelievably accurate digital blueprints of the road, down to the centimeter. We're talking exact lane markings, the height of the curb, everything. It's like giving the car a cheat sheet for the road ahead before its sensors can even see it. Okay, so the car has sucked in all this amazing data. It has this perfect, crystal clear picture of everything around it. So what's next? We move to the think phase. This is where the car's brain has to take all that raw information and actually make sense of it. And the car's brain, of course, is powered by artificial intelligence. Specifically, it uses things like machine learning and deep learning to understand what it's seen. And these systems aren't just trained to spot objects. They're trained to understand the whole situation and, maybe most importantly, to predict what might happen next. And deep learning is just incredible. It uses something called neural networks, which are kind of modeled after our own brains. Instead of a programmer writing a million rules like, if you see this, then do that, engineers just feed the system millions and millions of miles of real-world driving data. And the AI, it just learns the patterns on its own. It learns to see a pedestrian peeking out from behind a parked car, or to find a lane line that's almost completely worn away. All right, so the car understands what's around it. Now, for the second part of the thinking process, planning. This is where the car has to figure out its exact path forward, not just for the whole trip, but for every single moment of the drive. This image here really lays it out perfectly. Path planning is all about mixing two kinds of information. You've got the knowns from those HD maps, like where the lanes are and what the speed limit is. And then you combine that with the unknowns that the sensors are picking up in real time, like that other car that's suddenly merging. Put them together and you get a safe, smooth path forward. And you see, this planning is happening on two levels at once. There's the global plan. That's the big picture, the best route to get from your house to your office, just like your phone's navigation. But the real work is local planning. That's what's happening in the next 5 seconds. It's the car deciding to shift over a few inches to miss a pothole, or to slow down because someone up ahead hit their brakes. It's the constant, real-time dance of driving. And here's a really cool way to think about how some of these algorithms work. They basically create a virtual force field around the car. Your destination acts like a magnet pulling the car forward. At the same time, every obstacle, other cars, a curb, a pedestrian, creates a repulsive force pushing the car away. The car then just finds and follows the path of least resistance through this invisible digital field. Pretty clever, right? So we've sensed the world and we've thought about a plan. Now for the final step. Act. This is where the rubber literally meets the road, where all those digital decisions become physical movements. This is it. This is the plan becoming reality. The car's computer sends out thousands of precise electrical signals to the steering, the accelerator, and the brakes. It's basically saying, turn the wheel 5.2 degrees left. Now apply 10% throttle. This happens hundreds of times a second, letting the car execute its plan with a smoothness and precision that, let's be honest, most of us humans just can't match. No, with all of this amazing tech, you might be thinking we're ready to just kick back and let our cars drive us everywhere. Well, not so fast. This brings us to a really important reality check. Not all self-driving cars are the same, and there's actually an official scale for this stuff. The Society of Automotive Engineers, or SAE, created this handy 6-level scale. Level 0 is, a basic car. Levels 1 and 2 are what we call driver assistance. The key word there is assistance. You still have to pay attention. The huge leap is to level 3, where the car is actually in control under certain conditions. Level 4 is truly driverless, but only in a specific mapped area. And level 5, well, that's the dream. A car that can drive itself anywhere, anytime. So where are we today, right now? Despite all the marketing and all the hype, almost every advanced system you can buy today is at level 2. And this is the part you really need to remember. At level 2, the driver is still 100% legally responsible for whatever the car does. You have to be ready to take over in a split second. And that jump to the higher levels, it's a massive one. There are still some major hurdles in the way. Things like heavy snow can still throw off the most advanced sensors. But you know what the biggest challenge of all is? Us, humans. We're chaotic, we're unpredictable, and that makes us a real headache for an AI to try and figure out. And that leaves us with the biggest question of all, one that goes way beyond engineering. In a no-win situation, a truly unavoidable crash, how should we program a car to decide what to do? Should it protect its passenger at all costs, or should it try to minimize the total harm? And when something does go wrong, who's responsible? The owner? The programmer? The manufacturer? These are the huge, thorny questions that we all have to figure out as we drive into this autonomous future.